Hi there, I'm Chris Timperley from Carnegie Mellon University, and today I'll be presenting our Journal First paper, Understanding and Improving Artifact Sharing in Software Engineering Research, which was originally published at Empirical Software Engineering last year. So, what is an artifact? Artifacts are the tools, benchmarks, data, and other additional resources that are created during a study. Since long before there was any formal process for sharing artifacts, authors have been including those artifacts in their publications. These artifacts are usually included as a URL that points to a web resource. That resource might be a personal or group website, a repository on GitHub or Bitbucket, or part of an archive such as Zenodo or Figshare. And the archive itself can be packaged in countless ways. It could take the form of a Docker container or a virtual machine image, a compressed archive, source code, raw data, or many other forms. As part of this study, we found that most software engineering publications informally include such artifact links, and that the percentage of papers that include artifacts has been steadily increasing over the last several years. This sharing of artifacts has a number of important benefits to the community. Sharing artifacts can help to improve our understanding of an associated paper by providing extra data and results, or providing an implementation of a technique. Artifacts can increase our confidence in the result of important papers by allowing those results to be reproduced and analysed. And finally, artifacts such as benchmarks, tools, and datasets can be extended, reused, and compared by others for years to come. So, while there are some great benefits to informal artifact sharing, there is a major problem. When you click that artifact URL, you don't really know what you'll get. In some cases, the link might be dead, or the artifact may have never been uploaded at all. If you manage to download the artifact, you might find that it's missing important files and doesn't build. You might try to contact the author of the artifact, but get no response, or find out that it's no longer maintained. Even if you manage to build the artifact, you might get dramatically different results to those in the paper, or the artifact might otherwise not live up to its description in the paper. So, back in 2011, the organisers of ICSE FSE decided to tackle this problem by holding the first artifact evaluation process in the software engineering research community. The authors of accepted papers were given the chance to voluntarily submit the artifacts associated with those papers to an artifact evaluation committee who would review them, allowing any issues to be identified and addressed by the authors. In the years that followed, the ACM introduced its formal badging scheme that many of us are familiar with today, where papers that have successfully passed this process of artifact evaluation are awarded a badge. Fast forward to 2022, and now all three of the major software engineering conferences, ASE, FSE, and of course ICSE, have their own artifact evaluation track. This is great progress. However, despite the spread of artifact evaluation processes and the potential benefits of evaluation, we found from our data that relatively few authors choose to participate in artifact evaluation. That is, while most papers informally share artifacts, very few of those artifacts are actually formally evaluated. So, how can we get more participation in artifact evaluation and ensure that the community enjoys the potential benefits of artifact sharing? Before I talk about how we can bridge that gap, let me talk to you about public health. Whether it's tackling infectious diseases or combating addiction and substance abuse, it takes the medical community an average of 17 years to translate evidence-based practices from theory into regular use. In the worst case, half of evidence-based practices fail to make it into regular use at all. This gap between what we know and what we do occurs because laboratory conditions don't match the real world. It might be hard to convince doctors or patients about the effectiveness of a treatment. Application of a treatment could require particularly rare expertise. It might be unaffordable or inaccessible to those who need it the most, or you might be tackling the wrong population altogether. Implementation science is a relatively new discipline that seeks to systematically identify and close gaps between knowledge and practice, referred to as the no-do gap, and to accelerate the adoption of evidence-based practices by identifying and addressing the barriers that slow or halt the uptake of those practices. Thankfully, one of the authors on this paper, Lauren Herckis, is an expert in the field. We teamed up with Lauren to view the processes of creating, sharing, using, and reviewing artifacts through the lens of implementation science. Specifically, we set out to understand whether the software engineering community perceives the inherent value in artifacts, and to identify the barriers that impede or halt the creation, sharing, use, and review of high-quality artifacts. To answer our research questions, we conducted a mixed method study with 3 components: a publication survey, AE data collection, and an author questionnaire. In the first component of our study, we set out to measure the prevalence of informal artifact sharing within software engineering research papers. Specifically, we looked back over all main track publications at ASE, FSE, ICSE, and MC between 2014 and 2018 inclusive. We downloaded the PDFs for those papers, semi-automatically identified artifact URLs that they contained, and then manually checked the liveness of those URLs. In total, we identified 899 artifact links across 1,434 papers. Next, we collected data on artifact evaluation participation rates. To do so, we identified all venues within our publication dataset that had hosted an artifact evaluation track. We reached out to the chairs of their respective artifact evaluation committees to ask for the number of papers that were submitted to and accepted by that committee. And finally, we combined that data with the output of our publication survey to determine the proportion of informally shared artifacts that had been reviewed. Thirdly, we carefully crafted an online questionnaire designed to elicit the perceptions of and challenges experienced by artifact creators, users, and reviewers. We sent out our survey to 698 authors who had recently published a paper at ICSE, FSE, ASE, or MC in 2018. We received 153 responses, many of which were very detailed, giving us a very strong 22% response rate. This shows that the community really cares about this topic. Finally, we performed an extensive qualitative analysis of the survey responses, which is described in detail in the paper. After we'd completed each of these study components, we combined their qualitative and quantitative results to answer our research questions. In answer to our first research question, we found that yes, the software engineering research community does perceive inherent value in artifacts. From the results of our publication analysis, we found that an increasing majority of software engineering papers include an artifact URL. The fact that artifact evaluation has not only persisted, but spread since its introduction to the software engineering research community in 2011 also shows that the community cares about its artifacts. From our author questionnaire, we also found positive sentiments about artifact sharing. Notably, one of our respondents pointed out that entire research areas have died out because the early work in that area had no artifacts available, and that the cost of re-implementing and extending that work is just too high. After establishing that the community does perceive inherent value in artifacts, we turn our attention to the challenges that artifact creators, users, and reviewers face. This table shows the results of our qualitative analysis of survey responses. Specifically, we identified 12 high-level challenges that affect creators, users, and reviewers in different ways. Unfortunately, I don't have time to go into all of these challenges, but let's take a look at a few. One of the most prevalent themes to emerge from our analysis was a feeling amongst authors that submitting artifacts for evaluation is not worth it, and in some cases, that it isn't worth sharing artifacts at all. Authors feel that there is a lack of compelling incentives, that their efforts are not recognized, and that their time could be better spent working on the paper itself rather than the artifact. In other cases, authors feel that the risks associated with submitting or sharing their artifacts outweigh the potential benefits. Those risks include squandering future publication potential, being scooped, or that important mistakes might be discovered. Authors also highlight a lack of clear standards and guidelines as a challenge that affects both creators and reviewers. The meaning of individual badges and the differences between those badges are cited as being particularly vague and confusing. This situation dissuades some authors from submitting their artifacts for evaluation. In cases where artifacts are submitted for evaluation, the creator and reviewer of the artifact may have differing expectations, leading to inconsistent evaluation outcomes. Artifact reviewers highlight that it's unclear how thorough their review process should be. On the one hand, reviewers could simply follow the scripts provided by the authors without inspecting the artifact more deeply. By doing so, those reviewers could replicate the same mistakes made by the authors rather than identifying deeper methodological issues. On the other hand, reviewers could perform a much more extensive deep dive into the artifact and its inner workings, but doing so would take a considerable amount of time. Much more fundamentally, we observe a spectrum of opposing views on the purpose of artifact evaluation. On one end of that spectrum, some authors think that existing review processes are too heavyweight and that getting an artifact badge should be easier. On the other end, authors think that artifacts should be mandatory and that a failed artifact evaluation should be grounds for paper rejection. After answering our research questions, we conducted a secondary analysis to examine how the 12 high-level challenges relate to one another. To perform our secondary analysis, we used another framework from the social sciences, Diffusion of Innovations. Diffusion of Innovations seeks to explain how inventions and ideas are adopted by and spread through populations over time. Diffusion of Innovations is used to look at the gradual adoption of technologies such as smartphones, the internet, and the printing press. For our analysis, we treat artifacts themselves as innovations and use Diffusion of Innovations and the results of our study to understand how artifacts spread throughout the population. DOI, or Diffusion of Innovations, uses 4 dimensions to explain innovations. Firstly, the intrinsic qualities of the innovations themselves. Secondly, the communications channels through which innovations are spread. Thirdly, how those innovations change over time. And finally, it looks at the larger social system in which those innovations take place. To understand what this analysis looks like, let's take a look at artifacts through the dimensions of communication channels and the social system. For communication channels, we identified several communication channels that are used by artifacts and examined the challenges that affect those particular communication channels. For example, artifact badges act as a communication channel between reviewers and prospective artifact users by providing a signal about the quality and claims of an artifact. The effectiveness of artifact badges as a signal of quality depends on the fidelity and consistency of the review process. When the criteria used to review artifacts is unclear and evaluation processes differ considerably, badges lose their effectiveness. Other communication channels include artifact links, personal correspondence between users and creators, artifact evaluation, and paper review. We also observed artifacts through the context of the wider research community. We observed that a lack of rewards for creators can lead to authors either not sharing their artifacts or otherwise devoting fewer resources to artifact creation, sharing, and maintenance. Similarly, a lack of rewards for artifact reviewers can lead to a less effective review process, ultimately lowering the quality of artifacts. As a consequence of the lack of incentives for both creators and reviewers, issues go unnoticed or unresolved during review, and potential artifact users have to deal with issues such as the inability to install or run the artifact on their machine, incomplete documentation, or perhaps an artifact that does not match its description in the paper. In the final part of our study, after examining the challenges of creating, using, sharing, and reviewing artifacts through the framework of Diffusion of Innovations, we derived a set of recommendations. Following best practices from implementation science, we derived a small number of high-level recommendations aimed at particular stakeholders within the research community. Not only did we consider artifact creators and reviewers, but also those that advise and mentor creators, process organisers such as artifact evaluation committee chairs and conference chairs, and community leaders such as professional organisations, steering committees and funding agencies. In total, we came up with 8 high-level recommendations listed in this table. Let's take a look at 3 of them in more detail. Inconsistent and poor reviews were cited by a number of our participants as a reason for not submitting artifacts for evaluation. Additionally, reviewers complained that the purpose and extent of the artifact evaluation process was not clear. To tackle these problems and to align expectations between authors and reviewers, we proposed that artifact evaluation tracks clearly communicate the purpose of the artifact evaluation and the extent to which artifacts will be evaluated. The same set of evaluation criteria are communicated to both authors and reviewers, and that artifact evaluation committees improve consistency and build institutional knowledge by retaining members of the committee, performing a retrospective at the end of each evaluation process, and allowing the programme committee to share confidential remarks with the AEC. Improving the rewards of creating, sharing, and reviewing artifacts isn't easy. The community needs to put more value into artifacts, and that won't happen overnight. But there are steps that we can take to improve the rewards for those doing the right thing. Hiring, reappointment, and promotion committees should consider the creation and sharing of high-quality artifacts. Similarly, when reviewing grant applications, funding agencies should reward applicants with an established track record of sharing their artifacts. Finally, professional organisations, funding agencies, and individual conferences should explore providing funding and resources for important artifact-related activities. This can take the form of hosting space, funds for continual artifact maintenance, and cloud compute credits or resources for conducting artifact evaluations. Finally, professional organisations such as IEEE and ACM, as well as the software engineering research community as a whole, is in a position to establish a common artifact description format. By following such a format, authors could help prospective artifact users and reviewers know what to expect and what claims have been verified. At a minimum, artifact descriptions could state the contents of the artifact, how those contents are related to the paper, and how the artifact can be used by others. Expectations about who will maintain artifacts and for how long could also be addressed by such descriptions. Going a step further, artifact descriptions could state the claims of the artifact, and evaluation committees could evaluate and verify those particular claims, helping to resolve the ambiguity of badges and increase the confidence in a particular artifact. To recap, in this paper, we set out to understand the challenges that affect the creation, sharing, use, and review of artifacts through the lens of implementation science. We identified 12 high-level challenges, used Diffusion of Innovation as a framework to understand the relationships between those challenges, and derived actionable recommendations targeted at specific subpopulations from our results. To read more of our recommendations, see our complete set of results, and learn more about our methodology, be sure to check out our paper and our associated artifact. Thank you for listening, and I look forward to answering your questions at the conference.